So in this video, I'm going to discuss the inversion of subsequences problem which occur in today's CODECHEF challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem is very simple. It is stated that you are given a permutation. Remember one thing, very important point. It is a permutation. What is a permutation? Permutation is an array of size n which contains all the elements from 1 to n in a jumbled manner, or even in the normal manner, doesn't matter. So what you have to do is you have to check, like you can eliminate, you have to check the number of subsequences which have the same number of inversions as the original permutation. Okay, like for this there are no inversions, right? So you have to check how many subsequences are there which can have no inversions. So you take out any subsequence from this array, it will work. So how many subsequences can be made from this array? That is 1 2 3 4 5, right? You can either choose this or not choose this. Just choose this or not choose this. So 2 to the power 1 2 3 4 5, and you have to minimum for a subsequence, the minimum length should be 1, right? So you can't like remove all the elements, so that won't work. So you have to remove this condition that all elements are not there. So this is how it works. So what now, the most important thing is that you have to check the elements which does not disturb the number of inversions. Okay, so how can we check it? You have to check all the elements in a permutation and check if all the numbers lesser than that element occurs towards the left of it, and all the numbers greater than that occurs towards the right of it. So for 1, all the numbers lesser than 1. Is there any number lesser than 1? No. So see, over left there is nothing. Over right, all the numbers are greater than 1. For 2, 1 is lesser than 2, so 1 is over here, and all the numbers greater are over here, right? So all of these elements are contributing nothing. Okay, are contributing nothing to this. So we can replace all of these elements. So how many permutations are possible for this? How many solutions are possible for this? It is 2 to the power 5. But since I stated that you can't make all of them 0, or you can't remove all of the elements, so you have to make 2 to the power 5 minus 1. But for this, check for 3. 1 and 2 are lesser than 3. So is there anything over towards the left? No, there is nothing towards the left. So this won't contribute. This is contributing. Okay, so we can't remove this. For 1, is there anything lesser than 1? No, but there is 3 towards the left, so we can't use this. This is contributing, so we can't remove this. For this 2, is anything lesser than 2? Only 1, but 3 is not lesser than 2, right? So we can't even use this. We can't remove this. For this 4, what are the elements lesser than 4? 1 2 3. See, 1 2 3, all of the elements are towards the left. And what are the elements greater than 4? 5 and 6. So all of them are towards the right. So we can remove this. For 6, 5 should be over here because 5 is lesser than 6, but is over here, so we can't remove this. And for 5, 6 should be over here, so we can't remove this. So what is the only possible? This is 4, right? So how many possibilities are there? 2 to the power 1, because only 1 is removable. So what is the answer? 2. And for this was 31. But there is one thing, how you're going to check this. Okay, so if you're going to check this on a big O n squared, like check all the elements towards left and all the elements towards right, you're going to get a TLE. Okay, so what the concept of max comes over here. What is max? Max, like if you know what is max is the minimum. Okay, the minimum number which does not occur in a permutation, which hasn't occurred yet. So for 3, okay, like let's go for the max, if in case you don't know this concept of max. 6 and 5. So for 3, what is the minimum which has not occurred? It is 1, right? Because this array would contain elements from 1 2 3 4 5 6. So what is the minimum element that has not occurred? It is 1. Now 1 has occurred, right? So we can't consider this, and 3 has already occurred. So what is the minimum element now? It is 2, right? So max, okay, max was over here, it was 1, now it is 2. So is 1 and 2 equal? Nope. Okay, so for now you have to check for 2. Now is 2 and 2 equal? Yeah, it is equal, right? It is equal. Remember one thing, it is equal. But over here one condition occurs, that is 2 present in its correct position. Now why the permutation, like I told you why permutation is a very necessary word in this question. So is 2 in its perfect position? If I would have sorted it, nope, 2 is in the second position, but over here 2 is in the third position. So in spite of 2 being a max over here, we can't work on that. Okay, we can't work on that. Over here also it was 1. Okay, I misjudged it. It was 1, but since the positions are not there, so we can't work on that because 1 should be over here. Now what is the max after this operation has occurred? Now see, 2 gets cancelled. Now 4 is the max, right? Now see, 4 and 4, okay, both are equal, but is 4 in the perfect position? Yeah, it is in the perfect one. 1 2 3 4, so it is in the fourth position, so we can take this, right? Now 6 is here. Now what is the max now after this? Because 4 gets cancelled out, so what is the minimum? It is 5, right? So 5 is the max. Are they equal? No. So this 6 gets cancelled out. Now 5 is again the max, right? But over here again that condition, is 5 the fifth element? Is it? No, it is the sixth element, so we can't use that also. So we can't use them, so we can only use this. So by using this max method, obviously this thing, I hope you know that you are going to use a frequency array for this. So by using this max method, you can get the number of element which does not contribute to the inversions, and you can delete them. So let's say it is count. Okay, count is the number of element which does not contribute to the deletion, so we can print 2 to the power count. But remember one thing, that if count is equal to n, then the answer would be 2 to the count minus 1. Okay, and never, don't forget to make that mod, whatever that was, 9 9 something. Okay, I don't remember. So that's it. Thank you.